Hello everyone. In the previous session, we discussed how to find the center of gravity using double integrals. Now, in this session, let me define two special functions known as beta and gamma functions. Now, why we need these special functions? Yes, beta and gamma function helps us to evaluate certain definite integral which are either difficult or impossible to evaluate by various known methods of integration. So, using beta and gamma function, we can easily evaluate those definite integrals. So, to do that, let me define beta and gamma function one by one. So, now let us define beta function. The definition of beta function is given by, or the beta function is defined and denoted by beta of m comma n is equal to integral of x to the power of m minus 1 into 1 minus x to the power of n minus 1 dx between the limit 0 to 1. Yes, of course, this is a line integral, not the double or a triple integral as we solved in a previous session, right? And what is m and n? M and n are greater than 0 or more than 0. They are positive. Now, the example for beta function is like this. If we have integral of x to the power of some number 6 into 1 minus x to the power of 7 dx between the limit 0 to 1. If we have this case, of course, the limit should be between 0 to 1 and I should have x power some number minus 1 minus x to the power of some number. Then in such cases, instead of evaluating this by the general definite integral method or by various known method, I can easily write this in terms of beta. That is, in place of m minus 1, we have 6. In place of n minus 1, we have 7. So, if I compare with this, I can write this as in terms of beta. So, if m minus 1 is 6, then what will be your m? M is equal to 7, right? If n minus 1 is equal to 7, then what is your n? N is 8. So, that means what the number we have in a given problem, that when I am going to represent in some of beta, that should be more than 1 times the given number, that is beta 7 comma 8. I can directly write it as beta 7 comma 8 instead of evaluating this one by one or by integration by parts, whatever the known methods. I can write directly beta 7 comma 8, right? And also I can define beta in another form, right? That is a trigonometric function form. So, if I substitute or by substituting or by putting x equal to sine square theta, if I substitute x equal to sine square, I can represent in terms of trigonometric function form the given beta function or defined beta function, that is dx will be 2 times of sine theta cos theta d theta, and of course have to change the limit, right? So, if x is 0, then theta is equal to sine inverse of 0, 0. If x is equal to 1, upper limit 1, then theta is sine inverse of 1. Yes, we know that sine inverse of 1 is pi by 2. Now, replace wherever you have x by sine square and replace your dx by 2 cos theta, sin theta, d theta, and of course we have to change the limits also. So, that beta m comma n can be rewrite as integral of x is replaced by sine square theta whole to the power of m minus 1 into 1 minus sine square theta whole to the power of n minus 1 into dx is 2 sine theta cos theta d theta, where theta varies from 0 to pi by 2. That is the limit of theta. So, I can simplify this, right? So, beta m comma n is nothing but integral of, I can take out 2 common, integral of, I can add the powers of sine here, sine 2m minus 1 and sine theta, so that we left with sine theta to the power of 2m minus 1, minus 2 plus 1 will reduced with minus 1. The same thing with the next one. So we have here sine square 1 minus sine square. We know the standard trigonometric formula, that is 1 minus sine square is nothing but cos square theta. So if I write it as cos square, then it becomes cos 2n minus 2 and cos theta to the power of 1. So that we have cos theta to the power of 2n minus 1 into d theta. Yes, this form of a beta function is known as a trigonometric. Of course, theta varies from 0 to pi by 2, is known as trigonometric form of the beta function, is known as metric form of beta function, right? And of course, to solve the problems which are in trigonometric form, I can reduce that function, or I can reduce that standard formula into some other or another form, and also the trigonometric form or a trigonometric function form is also known as Euler's integral of first kind. It is known as Euler's or Euler's integral of first kind, right? Now, how to define or how to rewrite that in another form? Yes, by this substitution, I consider let m is equal to p plus 1 by q. Let m is equal to p plus 1 by 2, of course, so that 2m minus 1 will be p, and also I consider n as q plus 1 by 2, so that 2n minus 1 will be q. Okay. So wherever you have m, of course I am not replacing a variable, I am not disturbing with the theta, just I am replacing the constant m and n values. So if I replace m by p plus 1 by 2 and n by q plus 1 by 2, the beta function reduces to beta of p plus 1 by 2 comma q plus 1 by 2 is in 2 times of integral sin theta to the power of p into cos theta to the power of q into d theta, where theta varies from 0 to pi by 2. Let me write one more step which is convenient or which is more suitable to solve the problem. That is, if I have an integral of this type, integral of sin theta whole to the power of p into cos theta whole to the power of q d theta, where theta varies from 0 to pi by 2, is nothing but 1 by 2 times of beta p plus 1 by 2 comma q plus 1 by 2. Now let me give an example which can be solved using a beta function. That is, for example, if we have an integral like this, sin theta to the power of 2 into cos theta to the power of 3 d theta, between the limit 0 to pi by 2, of course the limit must be between 0 to pi by 2, then only you can use this formula. Of course, if you are not, theta limit is between 0 to pi by 2, if you are able to rewrite that and if you are able to reduce that to a 0 to pi by 2, first you should reduce and then we can use the same formula, right? If you don't have the limit between 0 to pi by 2 and if you are not able to reduce, then you are not supposed to use the formula, okay? Then I can write directly in terms of beta now. In place of p, what we have? Yes, 2. In place of q, what we have? We have 3. So it is nothing but 1 by 2 times of beta 2 plus 1 3 by 2 comma 3 plus 1 4 by 2 is nothing but 2. So this is the way I can reduce the trigonometric form of a beta function to another form, so that I can solve the given definite integral easily using a beta function. Let me define gamma function. The definition of gamma function is the gamma function is defined and denoted by gamma n is equal to integral of e power minus x into x to the power of n minus 1 dx between the limit 0 to infinity where n is positive, n is greater than 0. So, let me give an example for gamma function, that is integral 0 to infinity e power minus x into x to the power of some number 6. Then dx is nothing but gamma. So, n minus 1 term is there. So, I should consider nth term, that means the 7, or you can write like this, comparing your n minus 1 equal to 6, in place of n minus 1 we have 6. So, that n equal to 7. So, gamma 7 is integral of e power minus x power 6 dx can be replaced by gamma 7, or in particular I need a particular result. What is that? Yes, if n is 1, what is our gamma 1? I should know. Gamma 1 is integral e power minus x into x power 1 minus 1 is 0 dx between the limit 0 to infinity. Okay. So, if I define gamma function for n equal to 1, we are getting this. Of course, x power 0 is 1 we know, and e power minus x integration is e power minus x by minus 1 between the limit 0 to infinity, or if I apply the limit minus of e power minus infinity minus e power minus 0, or it is nothing but minus of 0 minus 1, we know e power minus infinity is 0. Therefore, gamma 1 is 1. So, please remember the gamma 1 value, gamma 1 is 1. So, as we define beta function in another form, we can define a gamma function also, and one more thing is, we call this as a Euler's integral of second kind. Beta function defined in trigonometric form is called as the Euler's integral of first kind, right? So, this is our Euler's integral of second kind. Gamma function is called as Euler integral of second kind. Okay. Let me define gamma in another form, that is by substituting by putting x is equal to t square, I can define in another way, which is convenient or which is useful to solve the problems, that is dx equal to 2t into dt. Of course, have to change the limit. If x is 0, t is 0, and we know that x limit upper limit infinity, then t is also infinity. So, what we have? We have gamma n is equal to integral e power minus x into x power n minus 1 dx between the limit 0 to infinity. That can be rewrite as integral 0 to infinity e power minus t square into t to the power of 2 whole to the power of n minus 1 into dx can be replaced by 2t dt, or if I simplify, we have integral 0 to infinity e power minus t square t to the power of 2n minus 2 plus 1, we remains with 2n minus 1 into dt. So, this is another way of defining the gamma function. So, whenever we have integral of e power minus t square t to the power of 2n minus 1 dt, that can be replaced. So, of course, so whenever we have integrals of the form e power minus t square t to the power of 2n minus 1 dt 2 times, that can be replaced by gamma n, or in general means I replace x by t square, right? So, t square may be with z square, or it may be y square, or it may be theta square, or it may be again x square. That t square can be replaced by any other variable, or in general we have gamma n is equal to 2 times of integral e power minus z square into z to the power of 2n minus 1 dz between the limit 0 to infinity, or I can write it as x itself, right. Now, we have some standard properties on beta and gamma function. Let me prove those properties. That is, in that the first property is prove that beta m comma n is same as beta n comma n. So that means even if I interchange m and n, that beta value will not change it, right. So how to get that? So consider, or we know that the definition of beta function, we know beta m comma n is equal to integral x power m minus 1 into 1 minus x to the power of n minus 1 dx between the limit 0 to 1, right. So now in this I replace 1 minus x by y. So replace your 1 minus x by another variable y, that means put 1 minus x equal to y. Then what is dx? Minus dx equal to dy, or dx, which implies dx is minus dy, and of course have to change the limit of x in terms of y. So if x is 0, lower limit, y is 1. If x equal to 1, yes, y is 0. 1 minus 1 will be 0. Therefore, the above equation reduces to beta m comma n reduces to integral of, so x is given by, from this what is our x? X is nothing but, so I consider x to here and y to here, so that we have 1 minus y is nothing but x. So wherever I have x, that can be replaced by 1 minus y. So that is 1 minus y whole to the power of m minus 1. 1 minus x nothing but y to the power of n minus 1. Dx is minus dy between the limit, yes, 1 to 0. The limit of y is 1 to 0. And I have minus sign in the integral. If I interchange the limits of integration, that minus sign can be removed. That is integral 0 to 1. Now I write first y to the power of n minus 1 into 1 minus y to the power of m minus 1 dy. So compare with the standard definition. Wherever we have x, here in this place we have y. So in the difference between those two, for these two formula is we have x here and we have y here, that's all. And also in place of m we have n, in place of n we have m. So this can be defined in terms of beta, right. So that is beta n comma m. So whenever you have beta m comma n, you can replace that by n comma n, or even if I interchange m and n, that will not make any difference in our result. Now the second property is prove that gamma n plus 1 is nothing but n into gamma n. We are supposed to prove that gamma n plus 1 is n into gamma n. So to prove this result, let me define what is the gamma function now. So we know that gamma n is equal to integral of e power minus x into x power n minus 1 dx between the limit 0 to infinity. So what we need? Yes, in place of n we have n plus 1 here, right. So replace n by n plus 1 in the standard formula or in the standard definition of gamma function. I am going to replace n by n plus 1. So that gamma n plus 1 is equal to integral of e power minus x into x to the power of n plus 1 minus 1 will remain with n into dx between the limit 0 to infinity. Now integrate by parts. Between these two, I apply the integration by parts formula. In that, this will be the first function. I consider x power n as first function, and for e power minus x has second function. If I apply integration by parts, first function into integral of second function e power minus x by minus 1 between the limit 0 to infinity minus integral of second function into derivative of first function x power n derivative n into x to the power of n minus 1 between the limit 0 to infinity into dx, right. So, why we apply integration by parts? We are supposed to prove that as n into gamma n. So, here I can't define this as a gamma n because gamma n is given by x power n minus 1. So, here we have only n, right. So, that is why I integrate by parts. Now, this integral, if I apply the limit for this term, that is integrated term, if I apply upper limit e power minus infinity is 0, and if I apply the lower limit 0 into e power 0 will be 0, that means the first term reduces to 0. And what about the second term? Minus of minus plus, I can take out n common, so that plus n into, I remains with integral 0 to infinity e power minus x into x power n minus 1 dx. Now, go through with this integral. That integral 0 to infinity e power minus x into x power n minus 1 is nothing but gamma n. Therefore, we prove the required result gamma n plus 1 is n into gamma n. Now, let me prove the next one. Prove that gamma n plus 1 is nothing but n factorial for positive integers of n. Positive integer n. N is a positive integer. Then only I can use this formula because we are representing a factorial term. That is a known fact that factorial can be used only for a positive term, right. So, how to prove this? So, using the previous result, that is the second property, what we prove gamma n plus 1 is n into gamma n, right. Using that I can obtain. So, I'll write this as we know that result, right. We know that gamma n plus 1 is n into gamma n. I call it as equation 1. So, if I am able to write gamma n plus 1 as n into gamma n, then what is our gamma n in terms of gamma n into gamma n, or what is our gamma n minus 1, n minus 2, let me know that. So, let me replace n by n minus 1, so that to get the required result I am replacing n by n minus 1, so that here I remains with gamma n. If I replace n by n minus 1, then remaining value is n equal to, this will be n minus 1 into gamma n minus 1. Similarly, gamma n minus 1, as we define gamma n is defined as n minus 1 into gamma n minus 1, that is previous number of n. Here also n plus 1 previous number is n, right. So, instead of substituting in all the steps, let me define in general n plus 1 previous term is n, right. Similarly, n previous number is n minus 1. So, how to define gamma n minus 1? The n minus 1 previous term n minus 2. So, we can define gamma n minus 1 in terms of the previous term, that is n minus 2 into gamma n minus 2. Similarly, gamma n minus 2 is n minus 3 into gamma n minus 3. So, continuing this, I can define gamma 3. So, what is the previous number of 3? Yes, 2. 2 into gamma 2. Very good. Next, how to define gamma 2? What is the previous number of 2? Yes, 1. 1 into gamma 1. And we know the standard result of gamma 1, right. Next, I can't define that previous gamma 1, need not to define, because I can stop here, because it is defined only for the n is positive, right. Up to gamma 1 I can define. Now, substitute all the values in equation 1. Therefore, equation 1 becomes that is gamma n plus 1 is equal to n into, I replace gamma n. What is gamma n here? Gamma n is n minus 1 into gamma n minus 1. So, I replace that. So, that is n minus 1 into gamma n minus 1. I am not going to write gamma n minus 1 because I know gamma n minus 1 here. Gamma n minus 1 is n minus 2 into gamma n minus 2. So, n minus 2. Similarly, gamma n minus 2 is n minus 3 into gamma n minus 3 and so on. So, that I can continue up to 3 into 2 into 1 into gamma 1, right? Up to this I can write. Now, what is the n into n minus 1 into etc. up to 3 to 1. So, read it in a reverse order. 1 into 2 into 3 into etc. up to n means, yes, we know the standard form of that is n factorial into gamma 1. But we know gamma 1 value. Yes, what is gamma 1? Gamma 1 is 1. We define or we prove that in a definition part. Gamma 1 value is 1. So, gamma n plus 1 remains with n factorial because n factorial into 1 is nothing but n factorial. So, whenever we have gamma 6, then it is nothing but n plus 1 previous number n, right. Similarly, 6 previous number 5. So, I can write it as 5 factorial. So, whenever we have a gamma 6, it is nothing but 5 factorial. Now, let me prove one more and last property. Yes, that is gamma half. Prove that gamma half equal to root pi. So, it is a very useful result or a property we can say. So, in the so many problems in other fields also even in not solving the beta gamma function in some other definite integrals, if I am able to reduce that into a gamma form and if I left with a gamma half, we are going to use or we are going to represent gamma half by root pi. To prove the result, we know another form of or another way of defining a gamma function. Yes, that is we know that gamma n is equal to 2 times of integral e power minus x square into x to the power of 2n minus 1 into dx between the limit 0 to infinity. Yes, we defined this in terms of t and I think we proved it in terms of t and I define in general in terms of z, right. So, here I consider it in terms of x, okay. So, to prove the result, I am going to replace or I am going to substitute n by 1 by 2 because I need gamma half. In place of n, I have 1 by 2. So, put n is equal to 1 by 2. So, that gamma 1 by 2 is 2 times of integral 0 to infinity e to the power of minus x square into x to the power of 2n into 1 by 2 is nothing but 1. X power 1 minus 1 will be 0 dx, or gamma 1 by 2 is 2 times integral 0 to infinity e power minus x square. So, whenever you have a definite integral of the form integral 0 to infinity e power minus x square dx, of course, now you can't integrate this. Remember this step, we are going to use this. Whenever we have integral 0 to infinity e power minus x square dx, this can be replaced by in terms of gamma 1 by 2. 1 by 2 times of gamma 1 by 2 or gamma half can be replaced, and of course we are going to prove gamma half as root pi, right. So, your integral 0 to infinity e power minus x square dx will similarly I can define it in terms of y, that is gamma half is equal to 2 times of integral 0 to infinity e power minus y square dy. Okay. Now, I multiply both the equation. If I consider 1 and 2, so 1 equation 1 into equation 2, I consider the multiple of equation 1 and 2. So that gamma half into gamma half will be gamma half whole square, right? And the second part our LHS is 2 2s are 4 times of integral 0 to infinity e to the power of minus x square into e power minus y square dx dy. I think I skipped one step. Instead of writing both line integral, I multiply directly because both have the same limit, and we have 2 to the 4. Multiple single integral e power minus infinity or line integral e power minus 0 to infinity e power minus x square e power minus square x y square dx dy. Now simplify this, that is 4 times of integral 0 to infinity e power minus of x square plus y square dx dy. I hope you all remember with the same problem that we solved by polar coordinate form or by changing the order of the given double integral into a polar form, right? Yes, replace or substitute x is equal to r cos theta and y equal to r sin theta, so that dx into dy is r dr d theta and x square plus y square is nothing but yes r square, and r varies from 0 to infinity where theta varies from 0 to pi by 2. This is a standard polar form, that is a changing the evaluation of double integral by changing it to polar form or polar coordinate. So that is 4 times of integral 0 to pi by 2 integral 0 to r e power minus r square into dx dy is r dr d theta. So if I replace x square plus y square by r square and dx dy by r dr d theta, and the limit of r is 0 to infinity and theta is between 0 to pi by 2, we left with this, or I can split like this 0 to pi by 2 d theta into integral e power minus r square r dr between the limit 0 to infinity, so that 4 times of theta between the limit 0 to pi by 2, and this can be evaluated by again substitution, that is put r square equal to t, so that 2r into dr is dt, right? Or if theta is r equal to 0, t is also 0. If r equal to infinity, t is also infinity. So I can replace this as integral 0 to infinity e power minus t r into dr is dt by 2, or 4 times of pi by 2 upper limit lower limit 0 into 1 by 2 times of e power minus t integration e power minus t by minus 1 between the limit 0 to infinity. So 4 get cancel, we replace pi into upper limit 0 lower limit 1. So minus of minus plus pi. So gamma half whole square is pi, or what is gamma pi or gamma half? So gamma half is root pi. So remember the result, gamma half has root pi, and one more result, that is this one, that is whenever we have integral e power minus x square dx, that can be replaced by root pi by 2. Okay. Now we have the relation between beta and gamma function. So let me prove that result, that is a standard result in in point of your examination. It is a compulsory question. We are supposed to get the relation between beta and gamma function. So relation between beta and gamma function. That is, prove that beta m comma n is gamma m into gamma n by gamma m plus n. So to prove this result, we are using the definition of beta and gamma. Okay. So we know that, So the proof of that relation is, of course I am telling you this property is, or the relation is important one. So we know that beta m comma n in terms of trigonometric function is 2 times of integral sin theta to the power of 2m minus 1 into cos theta to the power of 2n minus 1 d theta between the limit 0 to pi by 2. Theta varies from 0 to pi by 2. Also, similarly, we know gamma definition. Let me define gamma n in terms of x, that is gamma n is 2 times of integral e power minus x square into x to the power of 2n minus 1 into dx between the limit 0 to infinity. Similarly, gamma m is, I define 2 times of integral e power minus y square y to the power of 2m minus 1 dx between the limit 0 to infinity. And also I define gamma m plus n, that is gamma m plus n is 2 times of integral 0 to infinity e power minus r square, I consider it as r square, into r to the power of 2 times of m plus n minus 1 into dr. Yes, of course here dy. So if I have n here, then it should be 2n. If I have m, then it should be m. If I have m plus n, of course, m plus n, then it should be r to the power of 2 times of m plus 1 minus 1 dr. Now to get the required result, we are going to multiply these two. So consider gamma m into gamma n, that's equal to, so the multiple is 2 2s are 4 times of, again instead of writing the line integral, I write the double integral 0 to infinity, because the integral limits are same, I can write directly. So e to the power of minus x square e power minus y square into x to the power of 2n minus 1 into y to the power of 2m minus 1 into dx dy. Now to get the result, because I have now gamma m into n, so this should be replaced in terms of beta and gamma m plus n, right? So to get that result, we define beta in terms of sin and cos. So let me represent x and y in terms of r cos theta and r sin theta. So now put x equal to r cos theta and y equal to r sin theta, so that x square plus y square equal to r square, and we know that dx dy will be r dr d theta, which is a polar form, right? And if x and y limits are, if x comma y varies from 0 to infinity, we know that r varies from 0 to infinity, and theta limit is 0 to pi by 2. Just substitute the values, right? So that we remains with gamma m into gamma n is equal to 4 times of integral 0 to pi by 2. I write first limit as theta limit, then 0 to infinity e to the power of, I can add the powers of exponential term, that is I can take out minus common, so that x square plus y square we have, that can be replaced by minus r square into x is nothing but r cos theta whole to the power of 2n minus 1, r sin theta whole to the power of 2m minus 1 into r dr d theta. Now simplify the powers of r, that is 4 times integral 0 to pi by 2 integral 0 to infinity e power minus r square into, I write for sin theta to the power of 2m minus 1 into cos theta to the power of 2n minus 1 into, we have r powers, right, r to the power of 2m minus 1 into r power 2n minus 1 into r dr d theta, right? Now I split the theta variables to theta limit integrals and r to r integrals. I separate like this, and I split the 4 as 2 into 2 times integral 0 to pi by 2. I separate the theta functions, that is sin theta to the power of 2m minus 1 into cos theta to the power of 2n minus 1 into d theta into 2 times of integral 0 to infinity e power minus r square into, so if I add the powers of r, we remains with r to the power of 2 times of m plus n minus 1 into dr. Now compare with the standard result of a trigonometric form of a beta function and this another form of a gamma function. I can replace the LHS is gamma m into n is nothing but, so this can be replaced by beta m comma n, and this can be replaced by gamma m plus n. So we have our required result, beta m comma n is nothing but gamma m into gamma n by gamma m plus n. So whenever we have beta m comma n, that can be replaced by gamma m into n by gamma m plus n. So let me give an example. If I have, for example, if I have beta 5 comma 6, I can write it as gamma 5 into gamma 6 by gamma 11. And we know the gamma n plus 1 value, that is nothing but n factorial. If I use that formula here, instead the gamma 5 can be replaced by 4 factorial and 6 can be replaced by 5 factorial, 11 can be replaced by the previous number, that is 10 factorial. So if I simplify that, we can obtain the beta 5 comma 6 value. Okay.